All right. So remember from last time, we looked at that first basic concept that insects are cold-blooded, so they will grow slower at cold temperatures and faster at warmer temperatures. And when these are things that we can observe. Okay, so it takes a certain number of hours to go through the egg, the larvae, the pupae stages, depending on the species. So we learned that, and also that every fly has a threshold temperature, a temperature below which they will not develop. So that's our first basic concept. Now, the second thing that you need to know is that flies aren't nice enough to always grow at a single temperature, right? So we do all this lab work. We try to make it simple. We watch them grow at a standard temperature in a temperature chamber. But flies don't do that. They don't live at the single temperature. Most of the time, they're going to be outside, where the temperature insists on changing a lot. And this is just, say, your forecast for a decent day. The high of 67, a low of 46. The next day, it's a high of 75, a low of 53, etc., etc. If you live in Texas, it can be anywhere from freezing one day to 110 the next. So it just goes crazy like this. So that means that at any given point in time, at any given hour of the day, it might be above that fly's threshold temperature. So they're developing. But then later that night, it might dip below that threshold temperature. So they stop developing. So they're going to go at different rates depending on the time of day or depending on the average temperature of that day. So that seems like things are getting really complex, right? What we have figured out, though, is after a lot of observations, a lot of math and modeling and thinking about things, we figured out that we can describe how quickly or how slowly a fly grows by using a mathematical concept. We call this concept degree days or degree hours. So we can describe how fast a fly grows using a mathematical concept, degree days or degree hours. Okay, so what are degree days? Degree days, this is what I like to call a unit of heat time. So basically what this is doing is it is translating that idea that, okay, insects can need a certain number of hours at 27 degrees Celsius to get through their egg stage. They need fewer hours at a hotter temperature, more hours at a lower temperature. That's a mathematical, or we're able to describe that mathematically. So what we can do is we describe it as the total number or the total degrees of heat above a lowered threshold accumulated in one 24-hour period. Okay, so think about this concept. You've got your lower threshold, right, of your insect. Below that, it's not going to develop. Let's say, for argument's sake, it's below 50 degrees Fahrenheit. So once it hits 50 degrees, the insect is no longer going to develop. Okay, if it is above 50 degrees, though, it's going to continue developing. If it is just 1 degree above 50 degrees, okay, it's going to go really, really slowly, right? So if you're rearing this fly at 51 degrees, just barely above that amount of temperature it needs in order to develop, it's not going to go quickly. It's going to go really, really slowly. If it's at 52 degrees, it's going to be even faster. What if it's at 60 degrees? I mean, that's going to be an order of magnitude faster. What if it's at 90 degrees? It's going to go even faster. So we can count the number of degrees above a threshold temperature. And that is considered a degree day if we're counting the number of degrees above a threshold temperature in a day, in one 24-hour period. So let's say the average temperature is 60 degrees for the full day. Their threshold temperature is 50 degrees. That means 10 degrees or 10 degree days have accumulated in this 24-hour period. We can also do this for the hours. So degree hours are the total number of degrees of heat above a lower threshold accumulated in 60 minutes. So then we can do the average temperature. Let's say they experienced 50 degrees or 60 degrees for 1 hour. Okay? Then they've accumulated 10 degree hours. So it's a unit of heat time, the number of degrees above a minimum threshold in a given period of time. Now, we talk about degree days and degree hours simply because that's how we register temperature. If you go and you look at a temperature site, or you look at the weather, or, you ask Alexa or whatever for the weather report, you will see the average temperature over a day or the average temperature over an hour. That's what we do. We don't really record temperature over, the average temperature in the week. That doesn't help us. What's the average temperature in a minute? That doesn't help us. But you'll see a high and a low for tomorrow. Okay. So that's why we tend to do degree days or degree hours. What's neat about this degree day, degree hour thing, or this degree or this unit of heat times, it can be any unit of time. You could do degree seconds. You can do degree years, whatever it is. But it's the number of degrees above a threshold temperature in a given unit of time. So the way that we calculate that is we use this formula. We take the average temperature over whatever our unit of time is, minus a threshold. That threshold is individual for the insect, so that has to be figured out by lab work, remember? And we times it by whatever unit of time. So let's say we want to accumulate or figure out how many accumulated degree days happened. So to do degree days, we take our average temperature over a 24-hour period. We subtract out the minimum threshold for the insect, which we figured out in the lab. In the cases of this class, I'm going to give that to you. And we multiply it by the number of days we're looking at. So let's do a very simple calculation. Let's say we have a high of 90 degrees, a low of 60 degrees. The minimum temperature for the fly that we're looking at is 55 degrees. So now we have all of our unknowns, right? And we want to figure out our unit of time. How many degree days have accumulated over a 2-day period? So what we do is we take our average temperature. So the average of 90 and 60 is 75. We subtract out our threshold and we multiply it by a unit of time. So in this case, 2 days. So over 2 days, 40 degree days have accumulated. There have been 40 degrees above a minimum threshold in this time period. All right. So average temperature minus the threshold times a unit of time. Just say that 1,000,001 times. Average temperature minus the threshold times a unit of time. We can do the same thing for hours. So if we wanted to do accumulated degree hours, we take our average temperature, we minus out the minimum threshold, and we times it by the number of hours because we're doing time. So in this case, we'll take our average temperature over an hour. We subtract out the minimum threshold, which again is given to you. It's for that particular insect, and we multiply it by a unit of time. So let's say we have these exact same numbers again, right? So we've got a high of 90 and a low of 60. Let's say this happened every single hour for 2 days. Minimum threshold is 55. So again, our average temperature over the hour is 75 degrees Fahrenheit minus 55 degrees for our threshold times 48 hours. In this case, we have 960 degree hours. Okay? So this is what we're talking about. So again, all we are calculating here is a unit of heat time. So a degree day or degree hour is a unit of heat time, the number of degrees above a threshold in a given period of time. Okay, so if our threshold for this fly is, say, 42 degrees Fahrenheit, and the fly was hanging out at 70 degrees Fahrenheit, let's say it was in my house and I have my thermostat set at 70 degrees and it's 70 degrees is the high and 70 degrees the low, standard 70 degrees. We can figure out how many degree days have accumulated during that day. So if it's just hanging out for one 24-hour period in my house at 70 degrees Fahrenheit, let's figure out how many degree days it experienced. So we can just use this same calculation, average temperature minus the threshold times a unit of time. So the average temperature in this case is 70, right? High of 70, low of 70, average of 70. So then we take 70 minus 42 and we times it by 1 day. So 70 minus 42 times 1 equals 28 degree days. Easy, right? Average temperature minus a threshold times a unit of time. Pretty straightforward. So sitting in my house over this 24-hour period, 28 degree days accumulated for this fly. If I had a fly that had a higher threshold temperature, this would be a little different. If I had a fly that had a lower threshold temperature, this would be a little different. But remember, that will be given to you. Average temperature minus the threshold times the unit of time. So we could do the same exact thing for degree hours, right? So the number of degrees above a threshold in a given period of time, same exact idea. So again, remember, we've got this fly. Threshold temperature remains the same because it's given, 42 degrees Fahrenheit. My average temperature inside is going to be 70 degrees, okay? So in this case, if we're saying it's just in 1 hour, we're going to take 70 degree average on that hour minus the threshold of 42 equals times 1 hour equals 28 degree hours. So when you do this calculation, you have to be very, very careful about labeling everything. Know what you are talking about. Degree days is over a full day. Degree hours is over a single hour. Notice the numbers are the same, but the units are different here. All right, so degree days and degree hours. Now, this is what this looks like with a full life cycle going on here. So through this math, through our observation, we have figured out that a particular fly species needs a standard number of degree days or degree hours to make it through each stage of its life cycle. So each stage needs to accumulate a given number of degree days or degree hours in order to get to the next stage. The colder it is, the longer it's going to take them to get to that next stage. The warmer it is, the faster it's going to be. So this is something we have figured out by watching them in the lab at those standard temperatures and then calculating our degree days. So again, this is this life cycle, right? You got your eggs, your larvae, your pupae, your adult. And we have calculated through observation that Formia regina here needs 12 degree days to go through its egg stage. It doesn't matter what temperature it experiences it at. Those 12 degree days are required to go through to have enough temperature to fully develop. Okay, so once it gets through that 12, it's going to hatch into the first instar. If it's really warm out, it can get through those 12 degree days really, really quickly. If it's cold out, it could take days or weeks to get to those 12 degree days. It just depends on the temperature. It'll need 10 degree days to go through the first instar, 21 through the second, 45 for the third, 84 for the pupae. Okay, so it needs a standard number depending on the species. And we figure this out by calculating the number of degree days based on our life tables that you saw last time. All right, now this tends to be where I lose people a little bit. So I'm going to give you an example that I like giving to the police officers when I first try to explain this to them or to the lawyers. Okay, so here's an example from sort of real life. Let's say you can kind of think about this like you're saving up money. So let's say this is you. Hi, Vault Boy. Let's say you need to buy 5 things. You need to buy, a bouquet of flowers for your mom. You need to buy this super awesome looking notebook. You need to buy this really great necklace. You want a blender and you need to buy a new bike. Okay. Each one of these things costs a certain amount of money, right? You can go and look it up. That is a standard amount of money for that thing. If you change the type of thing, it might cost a little bit more, a little bit less. So like if you change the species, might be a little bit more, a little bit less. But these are the 5 that you want. This is what you're looking at. So you know that the flowers are going to cost $25. The notebook is $45. The necklace is $60. The blender is $95. The bike is $150. Okay, so you want to save up for these things. And let's say you want to save up for them in order. So you want to buy your flowers for your mom, then you're going to buy yourself a notebook, and then a necklace, then a blender, then a bike. Okay, but you need to save up for it, right? Now, you don't have all this money right now. Instead, you have to work for it. So you have to go to a job every day, and you have to save up your money in order to buy these things. Okay? So if you have a low paying job, it's going to take you a heck of a lot longer to get the money you need than if you have a high paying job. So let's say you make, exactly $25 a day. Okay? You know that in one day, you are going to be able to afford your flowers for your mom. It'll take you probably 2 days to go through to get the flowers and the notebook. It'll take longer to get the flowers and the notebook and the necklace. Now, if you have a high-paying job, let's say you make $100 a day, it's going to take you a heck of a lot less time. Like part of your day will take to get these flowers, and you can get that notebook on that same day. Cool. Okay, so the more money you make, the faster you're able to save up. The less money you make, the longer it's going to take you to save up. But if you earn different amounts of money each day, let's say you have an hourly amount of an hourly paycheck and you work different hours every day, it's going to depend on how many hours you have each day. That's going to change how long it's going to take you to save up for these things. Maybe one day you work a lot of hours, so you make more money. Another day you only work 1 hour, so you make less. So it can change back and forth. That's exactly what is happening here. We are seeing these flies go from needing this particular amount of degree days. So they need 12 degree days. That's just like you need $25 for those flowers. If it's really warm out, they're going to save up those degree days really quickly. So if you work a lot of hours one day, you're going to save up that money really quickly. If it's really cold out, it may take them several days to go through this. If you only work 1 hour a day, it's going to take you several days to save up that amount of money. Same exact idea. It's a standard amount that this fly needs to go through each individual stage. All right. So that's just the beginnings of figuring out these accumulated degree days and degree hours. Let me know if you have any questions.